So notice it says a parabola contains these 3 points. What's the equation of the parabola in standard form? So think back to when you guys worked with lines. This problem comes up a lot with lines, right? But with lines, what do you do first normally? You only need 2 points to figure out the equation, and you take the 2 points they give you and do what? You find the slope, and then you go from there. Okay? You could, though, if you wanted, build a system of equations if you had 2 points that you knew were in a line. Okay? So, for example, if someone gave me 2 points that I knew some linear equation, and I thought about y equals mx plus b. Remember, points are x, y ordered pairs, meaning I could put 8 in for y, while I put 5 in for x. That would not solve for me at all. But if I did that same thing with another point, that doesn't solve. But with these two things, yeah, that's not normally the way we do it, but we could do it that way, right? If we have 2 points. Okay? So that's kind of the idea here. But with a quadratic, the reason that we would need 3 points to be able to find the actual equation of the quadratic has somewhat to do with the shape. Okay? And think about the equation. If we're trying to come up with the quadratic equation, this is set in standard form, so I'm going to start by writing it in standard form. How many things do I need to figure out in order to have the equation of this quadratic? 3 things, my A, my B, my C, right? So that's why they kind of have to give me 3 points. 2 is enough for a line because there's only 2 pieces of information I need to know about the line to build its equation. But with a quadratic, there's 3 things I need to know. Okay? So I would have to have 3 points. So we're going to kind of use this idea because a quadratic equation doesn't have a consistent slope, so we can't use something like slope formula and go from there. But we can use this idea of that every point is an xy pair, that when that x is put into the equation, you know that that y turns out. So for example, -2, -4, that ordered pair tells me that when y is equal to -4, then x must be equal to -2. And at first, that looks a little bit ugly, but just clean it up a little bit. So -2 squared is 4. So that's like 4a. That's a -2b plus c equals -4. That's as good as I can get that. Okay? So that tells me nothing individually, but it at least gives me an equation that could be solved for a, b, and c if I had other equations in that system that also contained a, b, and c. So I could do the same thing for each one of these points. So one -1 is another point on the parabola. It can give me another relationship between A, B, and C when I plug this in for X at the same time I plug this in for Y. So if I plug in -1 for Y while I'm plugging 1 in for X. So that would give me -1 equals A plus B plus C. And then the same thing for 311. So I would have 11 is equal to 9a plus 3b plus c. So I have here a system of 3 equations with 3 unknowns, a, b, and c. I know I can solve this system using substitution and elimination. I know it's going to take more work than it takes with a system of 2 equations and 2 unknowns. Okay? So let's call this, just so we can talk about it together. So these numbers have nothing to do with actually solving the problem. It's just so we can communicate first equation, second equation, third equation. Does anybody see a way that they would start solving this system of equations? What would you focus on and what would you do? So this goes back to what we did before we started like our first unit. Sarah? Okay, so she's going to focus on canceling out the c's. So I can combine any 2 equations together, cancel out the c and get one new equation, and then I'm going to do that again with a different set. So let's say I decide to use the first one and the second one, and I'm going to multiply the second one by -1. Okay? So I'm going to combine together the first equation with the second equation when it's been multiplied by -1. So the first equation will look exactly what it looks like up here. The second equation will look like +1 equals -a minus b minus c. And so I'm going to have -3 equals 3a minus 3b. I'm going to put a little box around that for now. It's not my answer. I just don't want to lose track. Remember how there's like a lot of steps in this and we have to be a little bit methodical about it? And then you can choose any other two. I like this one has simple coefficients, so I want to use 2 again. So this time I'm going to use it with equation 3. So this time I'll combine equation 3 with equation number 2 when it's been multiplied by -1. So equation 3 looks exactly as it was up here. And then equation 1 multiplied by -1 again would be +1 equals -a minus b minus c. So I'm going to have 12 equals 8a plus 2b. So there's another equation that I know. So now I've narrowed my system down to 2 equations that only have 2 unknowns, and I should be able to find a and b. Somebody give me where you're going to look and what you're going to do with this system to find either a or b. Marcus? Okay. Okay. Sorry, I'll shut the door. So he's looking at the b's and saying he's going to get them both equal to 6 in order to cancel them. So, yes. Yeah. Absolutely. Did you guys hear what Brandon said? You could divide this one by 3 and that one by 2, and the b's will still both cancel that way as well. Okay. Either way is fine. Okay. Either way totally works. Yes?
Would it work if you solve for A,
Mm-hmm.
and then you plug in?
Yep, absolutely. You should get the same thing that we get. So I'm going to do it the first way that was mentioned. You guys do it the other ways. We should get the same values for A and B. We're doing the same process, just with slightly different methods. So times 2 and times 3. So I'm going to have -6 equals 6a minus 6b. And then I'm going to have 36 equals 24a plus 6b. And I'm going to have 30 equals 30a. And so a is equal to 1. And I now know one piece of my equation. That's not my final answer. My final answer is an equation. I'm just circling it so I don't lose it. Okay? So a is 1. How can I then go figure out some other coefficient that I need for this equation? Jonathan? Good. Plug in a. Now you could go back here, plug in a, and solve new systems. Or you can just go back right here, pick one of these, plug in a, and solve for b. Or if you did what Brandon did and you like divided this by 3 and divided this by 2, you would have even simpler versions of these equations. Or if you did what the other Brandon did, and you had solved one of these for a or for b and substituted in, you could substitute your value into the equation where you solved for a or b. But any of those equations, we can substitute that value in, and it will. So let's just say 8a plus 2b. So I'm going to get 4 equals 2b. So b is equal to 2. And then to find c, I have to go back to an equation that involves c with the other variables, or at least one of the other variables in it. I'm going to pick maybe the simplest one right here. Yeah, and I'm going to plug in a and b. So I'm going to take -1 equals a plus b plus c. So that's -1 equals 3 plus c. So c is equal to -4. So then my final answer to this problem, the equation of the parabola in standard form that passes through these 3 points would be x squared, because a is 1, or 1x squared, plus 2x, because b is 2, minus 4, because c is -4.